So this is what a parallelogram looks like. It's got two sets of parallel sides. These are parallel and those are parallel. So one length is 12 centimeters, one is 8, and one of the angles is 60. So I'm not going to call this one 60 because that looks like it's an obtuse angle. I'll call this one 60. All right, so we got a few different ways we can go about this, but does anyone remember the area of a parallelogram formula? Like how it would be presented to you in geometry class?
It's base times height.
Okay, base times height. So one way you could do this is you could say, all right, well, the base is 12. You have to be careful not to say that the height is 8 though, because the height is like, this is like what we call slant height. Height is straight down perpendicular. So we don't really know the height. But if you draw the picture, and especially if you draw in the height, hopefully you see, okay, well, since this has to be perpendicular, this is a right triangle, and I could find the height by doing a sine equation. The sine of 60 is equal to opposite over hypotenuse. So the height is 8 times the sine of 60. And I guess I'm going to have to use a calculator at some point. But right here I shouldn't need one because 60 degrees is the spot on the unit circle. That's square root of 3 over 2. So the height is actually 4 square root of 3. And so you could take that route if you wanted to. But that route does kind of depend upon you remembering the area of a parallelogram is base times height. And then that could give you 83.138 square centimeters. Now, again, there's nothing wrong with that, but I could see why someone would say, well, why does that really fit into this section? And I'd have to agree with that. Like, this is an old geometry thing, which, you know, especially those of you that are going to Calculus AV next year, you have to get used to, like, anything you've learned in past fair game to be thrown at you again, because that's what the AP test does. But, and then this is from last semester. But another option, one that would fit into what we've been doing, just a different approach on the question, is you could say, I'm going to, what was this, 60? I'm going to figure out the length of this diagonal. And you can figure out, I'll call it A. You can figure out the length of that diagonal with just looking at this triangle. You could do your law of cosines. So A would be equal to the square root of B squared plus C squared minus 2 A, B, cosine of the angle in between. So if you wanted to do that to find angle, or what I'm calling A, the length of the diagonal, you could figure out that that is about this. Then you could say, all right, well now for this triangle, I know all 3 side lengths, and also new in this section, we talked about how to find the area when you know all 3 side lengths. That's Heron's formula. So the square root of S minus A times S minus B times S minus C, or whatever you want to call them, the 3 lengths, where S is the semi-perimeter. So 8 plus 12 plus my answer for side A divided by 2 is S. Area is S times S minus A, S minus B, S minus C. That is 41.569 square centimeters. So, but why isn't this the same answer that I got doing it the other way? Right, and it's exactly half, right? Like this guy and this guy have the same amount of area. So you could times it by 2, and then you should get the same answer that I got doing it the other way. So I prefer the second way because it reinforces law of cosines to find the side length. It reinforces Heron's formula to find the area given all three sides. But technically, if you really know the geometry formula, it's probably easier to do it the other way, or quicker to do it the other way. That is the answer we got the other direction, right? Okay, because I erased it.